So there's one last thing we need to know about trig before we take the test. Alright, so if you're given a trig function in fraction form, you can find the other two trig functions. So this is how. So if I'm given the tangent of an angle is 3/4, I know that tangent is opposite over adjacent. So what that means is that the length of the opposite side is 3 and the length of the adjacent side is 4. So the best thing to do at this point is draw a triangle. Go ahead and mark theta. It doesn't matter which angle you pick to mark theta as long as it's not the 90-degree angle, which is right here. Alright, so here's our theta. I know my opposite is 3 because tangent is opposite over adjacent, and my adjacent would be 4. I knew this was the opposite side because I could draw the straight arrow to it. So I'm going to label my sides 3 and 4. So if I have a right triangle where I have 2 of the sides and I need the third side, what I can always use is Pythagorean theorem. This is why we did Pythagorean theorem in the beginning of this little section. So we use the Pythagorean theorem to find the last length. So 3 squared plus 4 squared equals c squared, because the hypotenuse is always c. 9 plus 16 equals c squared. 25 equals c squared. Take the square root of both sides and I find out that c equals 5. So once I have all three sides, the 3, the 4, and the 5, now I can say, well, the sine of theta is just 3/5, and the cosine of theta is just 4/5. So just give me another example. Given that sine of theta is 5/13, what is the tangent of theta? So I don't want this to be confused with, given the sine of 60 degrees is a number, what's the cosine of 30 degrees? Because that would be the same number. That's what we did when we said complementary angles have sine of one equals the cosine of the other. This is, if you're given sine of an angle in fraction form, you can figure out all the other trig ratios. So if it's asking for tangent, you would set it up, draw the picture of the triangle, pick a place for theta, label your opposite and hypotenuse. Right? You would want to find the adjacent side because tangent is opposite over adjacent, so you need the adjacent. So a squared plus b squared equals c squared. 13 goes in the hypotenuse spot of c, and then whether you put 5 as a or b really doesn't matter. So 25 plus b squared equals 169. Subtract 25 from both sides. B squared equals 144. Take the square root of both sides. Your b equals 12. So tangent is opposite over adjacent. Tangent of theta is 5/12. Last one, given cosine of theta is 1/2, what is sine of theta? Same thing. I'm going to draw a triangle, label my theta, label my adjacent and hypotenuse, because cosine is adjacent over hypotenuse. Use Pythagorean theorem. A squared plus 1 squared equals 2 squared. A squared plus 1 equals 4. Subtract 1 from both sides. Take the square root. A equals the square root of 3. That is the opposite side. Sine is opposite over hypotenuse, so square root of 3/2. And that's the one last thing.